All right, we're looking at an updated percent of smokers in the U.S. Given some data here. So we have ourselves a very non-straight graphic. You can see the ups and downs, the peaks and valleys. That's how normal data looks. And then we have from 1975 to 2008, we have like a segment, a line segment. We call that our linear model. So let's look at number one. Let's find the linear model, which represents the percent of U.S. citizens who smoke cigarettes from 1978 to 2012. Meaning, we're going to let 1978 be our starting time. So 1978, our starting value, which means we are going to use x equals 0. So for 1978, x equals 0. Remember, if we want to have a y-intercept, we need an x value of 0. So if x is 0 for 1978, then the y value for 1978, or the y-intercept, in this case will be 38. And that's an ordered pair, right? The y-intercept, b equals 38 in our model. So when we go to the slope, find the slope, the rate at which y changes when x increases by 1 year. Okay, so thinking about this, we need some points. Well, we know that at 1978 we have the point 038. If you look over here at 2008, we also know that the actual value for 2008 is a value of 21. Well, from 1978 to 2008 is 30 years. So that means I have an x value of 30, which gives me an ordered pair of 30, comma, 21, because the 21 goes with that dot. Okay. Actually, all of that there. Okay, so now that I have two ordered pairs, now I can find my slope. So I have x1, y1, x2, y2. So y2 minus y1 over x2 minus x1. So I end up with negative 17 over 30 as my slope. Now, if you want to change that to a decimal, because it does say for every 1 year, you can use negative 0.567, and that's fine, right? So our model in part C, y equals our slope, negative 0.567x plus 38, because our y-intercept is 38, and there's our slope. A negative slope implies our values are going down, and we can see that, right? Look, they're going in a downward motion. So it makes sense that our slope is negative. Now, we're going to look at questions 2 and 3 kind of together. All right, so question 2, was the decrease in the percentage of smokers in the U.S. constant, or did it vary? So this question is talking about actual decrease. Was it constant or did it vary? And then in the second problem, it said, or third problem here, does the model assume constant or varying? So let's go back to the picture. The actual, I'm going to show in yellow, right? Actual. Is that constant? No. So the actual varies because that's real life. Very few things are constant in the real world. However, the model, which I'll show in red, straight line. So the model, a linear model assumes a constant. That's why we can write an equation when we use a linear model, because we assume the constant change. It's very exciting. All right, so if the decrease had been constant, meaning we can use our model, what would be the estimate percentage of people in the U.S. who smoke at the turn of the century? Well, turn of the century would be the year 2000. So again, remember, that's a horrible color. In 1978, our X value was 0. So in 2000, well, that's 22 years later, so my X value will be 22. So I use my equation, negative 0.567 times 22 plus 38. When I plug that into my calculator, I end up, I'm going to round here, I get 25.53%. So roughly, at the year 2000, we would say there's 25.5% of people are smoking. And that leads us to number 5. Compare the estimate for the year 2000, right? Our estimate is 25.53% with the actual value from the graph. Okay, so let's go back to the graphic and look at 2000, which is right here, and the actual value is 23. So the actual value is 23%. So what's the difference there? Well, if you subtract The difference is 2.53 percentage points. Meaning the estimate, right? Because this right here is the estimate. The estimate is 2.53 percentage points higher. Well, we can go one step further and take, the absolute change is new minus old, which is our 2.53, and then divide that by the old, which is 23, which is roughly 0.11. That's an 11% increase from the actual value to the estimated. Lost the word there for a minute. That's a big difference, right? So whether you're talking about the change, relative or absolute change, right, it changes the way you talk about things. But this is the big key here, that there's 2.53 percentage point difference between the estimated and the actual, with the estimated being higher. And the last one, use the linear model to estimate the expected percent of smokers in 2011. Okay, once again, in 1978, our X value was 0. So 2011, how many years later is it? Well, you can subtract those two and find out there are 33 years between 1978 and 2011, so my X value is 33. So Y equals negative 0.567 times 33 plus 38. And we should get something very close to 19.3%, which is what we would expect it to be in 2011.